All right, D, another rational one. This one's tricky because look, in the top, gross, 4 terms. What does that tell you? That tells you, dude, you should probably try factoring by grouping. So let's factor this numerator by grouping. Remember, factoring by grouping, you probably know it as the squiggle method. So we got something like that right there, which means in our first set of terms, let's pull out a 3x squared. So I'll pull out a 3x squared. What are you left with? Well, in the 3x cubed, if you pull out a 3x squared, you're left with an x. In the second term, if you pull a 3x squared out of a negative 9x squared, you're left with what? A minus 3. Because negative 3 times 3x squared is negative 9x squared. All right, then what? We have a negative 3x plus 9. Let's pull out a negative 3. Because then we are left with, again, an x minus 3, which is what we want. We want the things in parentheses to be the same. Because now we can essentially like squiggle again. They both have an x minus 3 in common. So we pull out an x minus 3. What are we left with in the first term there? Well, we're left with a 3x squared. What are we left with in the second term? A minus 3. All right, let's keep going. X minus 3 up there still. 3x squared minus 3 means I could pull a 3 out of all of that, and I'd be left with an x squared minus 1. Holy moly, one more step. X squared minus 1 factors as x plus 1, x minus 1. It's the difference of squares. So my final result for that numerator is 3 times the x minus 3 I pulled out times the x plus 1, x minus 1 that I just removed from the, not removed, but discovered from factoring that difference of squares, x squared minus 1. So that will be over x cubed plus 4x squared minus 5x. Well, all of those have an x in them, so we should pull that out. What's left? X squared plus 4x minus 5, which is a quadratic that you can factor. So a power of x down there. Two numbers that multiply to negative 5 and add to 4 are going to be positive 5 and negative 1. So x plus 5 and an x minus 1. So that's what we get. Notice we have a whole. We should remove it and rewrite our equation. So our final simplified equation should be y equals 3 times x minus 3 over, times x plus 1 over x times x plus 5. Restrict the domain. X cannot equal positive 1 because we pulled out that x minus 1 factor. So what do we have? X-intercepts at 3, 0 and negative 1, 0 from the numerator. Y-intercept, where's the y-intercept? Well, we don't have one because we have a vertical asymptote at y equals, or x equals 0, so not applicable. Vertical asymptote, where is that going to happen? Well, degree of the denominator is 2, degree of the numerator is 2, so it's going to go to the coefficients. We have a 3 in the top, so y equals 3 is our horizontal asymptote. Sorry, I was supposed to be talking about vertical asymptotes, but that's a horizontal asymptote. What about a vertical asymptote? Well, that's going to happen at x equals 0 from that factor of x at the bottom, and also at x equals negative 5 from the other factor in the bottom. So the last bit was just the whole, which we found, which was at positive 1. So the whole will occur when x equals 1. Okay? So let's sketch this all together now. And what all do we have? We said we have an asymptote vertical at 0 and negative 5. So 1, 2, 3, 4, 5. Sketch it in. Just like that. We have one at 0 as well, so kind of remind yourself there, kind of make it look dashed or something. We have a horizontal asymptote at y equals 3, so let's go 1, 2, 3, dash that in. Okay, what else? We know we have a hole at 1, so let's remind ourselves that we have a hole there. And what else? X-intercepts at 3, so 1, 2, 3, 1 right there. And at negative 1, so 1 right there. So this one's going to be kind of interesting. What is it going to look like? Well, I think the easiest place to start would be all the way to the left here, which has to be up like that because we don't have any x-intercepts down here. So we have to be up because of that asymptote going up. What else? Denominator Multiplicity is 1, which means on every single other side of the asymptote, vertical asymptote, I have to be on the opposite side. So since I'm up there, I have to be down here. So I start down, I'll come up, I will hit that x-intercept right there, I will cross at that x-intercept, and I will continue up as I approach that asymptote. I have to continue up because I do not have any other x-intercepts between that x-intercept and that vertical asymptote. Since that thing is up, I have to start down again because the multiplicity of everything is 1. So the multiplicity of the factor creating that x-intercept is 1. So I look like that, I cross through that x-intercept, and there we go. Let's show the hole. So erase that right there, replace it with a hole, and boom, baby, we got it. It looks awesome.